Hello everyone. We are going to learn about secant theorem today with Nicole Wooten and Soo-hyun Im. Secant theorem. Let's draw a circle. And from the external point P to a circle PXY, PUV, the secant theorem is the product of PX, PY equals to product of PU times PV.
Let's learn some terminologies before we start proving our theorem. Here's a circle with a center. And first one is radius. The common distance r from the center to the points of the circle is a radius. Chord. A chord is any line segment joining two points of a circle. And next one is a secant. A line segment that extends a chord beyond circle is a secant. And last, tangent and point of tangency. A line is tangent to a circle if it meets the circle in exactly one point. So point of tangency is the point of intersection between a circle and a tangent to the circle. In our theorem, there is a circle with a center and an external point P, X, Y, and PUV. That is. Next thing we're going to learn about is inscribed angle. There is a circle. In a given circle, the angle formed by two chords that shares endpoint, which is a vertex, is called inscribed angle. In our theorem, draw the chord and XYU, and that is inscribed angle, and XVU is inscribed angle. In order to prove our secant theorem, it will be useful to use a similar triangle theorem. In relation to definition of similar triangles, there are following properties. The corresponding angles are equal in measure. The corresponding sides are proportional. Two triangles that have the same shape but not necessarily the same size said to be similar to each other. There are three different criteria on this theorem. First, side angle side a similar triangle, known as SAS, if AX over AB equal to AY over AC proportional, and angle A is equal to angle A, then triangle ABC and triangle AXY, small triangle and a big triangle, must be similar. Next one is side similar triangle theorem, SSS. There are two triangles ABC, DEF. If AB over DE, the corresponding side, equal to BC and EF, BC over EF equal to CA over FE, if the corresponding sides are all proportional, then triangle ABC and DEF must be similar.
Angle similar triangle theorem. The last theorem is AA similarity triangle theorem. This theorem states that two triangles are similar if they have two corresponding angles that are equal in measure. So in this case, triangle ABC is similar to triangle DEF if angle A and D are congruent and angle B and E are congruent. we're going to prove this. In triangle ABC, angle C is 180 degree minus angle A plus B because three inner angles in one triangle are 180 in total. Since angle A is equal to angle D and angle B is equal to angle E, by assumption, 180 minus angle A plus B is equal to 180 minus angle D plus E, which is third angle F in triangle DEF. In our proof, PXV and PUV are similar by this theorem, AA postulate. Similar triangles and circles. There are two cases that we can see similar triangles in a circle. One is when P is inside of the circle. The other is when P is outside of the circle. For both cases, we have the equation Px times Py is equal to Pu times Pv. Let's look at the first case when P is inside of the circle and prove this equation. Draw the line segments xy and uv as shown and connect x and v and u and y, and x and u and v and y. And observe the angle uxy is equal to angle uvy since these inscribed angles obtain the same arc uy. Next, observe the angle xpu is equal to angle vpy since these are vertical angles when P is inside of the circle. Therefore, we have triangle PXU and PVY is similar by AA postulate. Thus, PX over PV is equal to PU over PY, so PX times PY is equal to PU times PV. This is applied to the second case as well. Draw a second line PY and PU from the outside the angle like this and let X and V the points where second line met the circle. Connect X and U and V and Y. And then angle P is common and angle PYV is equal to angle PUX since they have the same arc XV. Therefore, triangle PUX and PVY are similar triangle by AA. So PX over PY is equal to PU over PV. And we have Px times Py is equal to Pu times Pv. We're going to use this in our proof. We have a circle and point P outside of this circle, and we draw the secant lines which are Py and Pv. Then Py meets the circle at point X and Pv meets the circle at point U. And we want to connect X and V and U and Y to make two triangles, and they meet at Q. Do you see two similar triangles? PUY and PXY are similar. How those two triangles are similar? We can use AA similarity. Let's find two pairs of angles that are congruent. First, angle P is common. And we have angle PYU and angle PVX are equal since if you look at the arc XU, there are two inscribed angles by arc XU which are angle PYU and angle PVX. Hence, they are equal, and triangle PUY and triangle PXY are similar. So, PX times PY is equal to PU times PV. Here is a special situation. When P is outside of the circle and PX is tangent line of the circle, PX is our tangent line, and draw line through P that pass through the circle and the line meet at the circle at U and V. Then angle XVP is an inscribed angle. Therefore, angle XVP is half of arc XU. Angle UXP is formed by a tangent and secant and half of arc XU. Then angle UXP is equal to angle XVP, and we also know that angle P is common. So PVX and PXU are similar triangles by AA similarity triangle theorem. Since the length of corresponding sides of similar triangles are proportional, PV over PX is equal to PX over PU. Using cross property, PX times PX, which is PX squared, is PU times PV. This theorem is called tangent secant power theorem, and it says if a tangent and a secant are drawn from an external point to a circle, then tangent square is secant's external part times entire secant, and those which are in parentheses, they are all length. Anyway, in this case, PX times PX is PU times PV, which is PX squared is PU times PV. Here's an example. PC is 8, CA is 10, PB is x plus 4, and BD is 3x plus 9. What is the measure of chord DB? So by using our secant power theorem, we can easily set the equation like PC times PA is PB times PD. This is going to be 8 times 18 is equal to x plus 4 times 4x plus 13. This is going to be 144 is 4x squared plus 29x plus 42. We can simplify this. 4x squared plus 29x minus 102 is equal to 0. So our x are negative 9.841 or 2.591. But since x is length and x could not be negative number, so our x is 2.591. So our dB is 3x plus 9, which is 3 times 2.591 plus 9. It's gonna be 16.773. This is it. Thank you.